7-5 coordinate geometry. I can identify polygons in a coordinate plane.
Which this really isn't so much about identifying polygons as it is about understanding what happens when lines, with various lines and polygons, which we broke down into just lines. Vocab, the big vocab word was slope, and this is a review. We have, let's see, 5 different ways of defining slope. All of those should make sense to you. The reason we went with the cheat sheet is because this is probably the one that is the most unfamiliar to you, but all of them are the exact same thing. It's just a way of looking at or defining slope. Parallel lines never intersect. Our parallel means they never cross, and perpendicular means they intersect at 90-degree angles. Number 2, interesting slope. What's the slope of a horizontal line, you guys?
0.
Ask it again. What's the slope of a horizontal line?
0.
What is the slope of a vertical line?
Undefined.
It's not possible. It's undefined. Okay, remember the slope of a parallel line, the slope of a horizontal line, we would have a rise of 0 and a run of x, right? Which actually anything, 0 divided by anything is 0. The slope of a vertical line, you would have a rise of x and a run of 0, and anything divided by 0 equals error, undefined. Doesn't work. Good. So 2 lines with equal slopes means they're what?
Parallel.
Okay, the rest of you, are you paying attention to me? This video is going to get really long if I have to keep pausing. 2 lines with equal slopes means the lines are what?
Parallel.
Parallel lines. 2 lines whose slopes are perpendicular mean they have a product of what?
-1.
Okay, I don't know if I said that right. Two lines that are perpendicular have a slope of,
-1.
the product of their slopes is -1. Did I say it right or wrong?
You said it right.
I did? Okay, cool. So, we'll get to that in a second. When I go to the graph paper, when you go to your graph paper to look, we have examples of what we just talked about. So we have line B and line A. They have the exact same slopes, therefore they're what, you guys?
Perpendicular.
Okay, we're not listening again. You guys understand this video is not for me, right? I'm going to ask the question again. Line A and line B. Look at them. They have the exact same slopes. Therefore, they are what kind? They are what?
Parallel.
In relationship to one another, parallel. Line C intersects them so that we form 90-degree angles. Therefore, we know the slope of line C and the slope of line B. When you multiply them together, you get what?
-1.
-1. What is another name for line C because it crosses 2 parallel lines? What's another name for line C, you guys?
Transversal.
That's a transversal. It just happens to be that this transversal forms 90-degree angles because when we calculated the product of the slope of the transversal and A or B, we got -1. That is explained right here. The line C perpendicular line A and B. Here's our math in which we did the product of the slopes. Also remember to calculate slope, rise over run, or change in Y over change in B. All of these guys right here, this whole section right here, represent change in Y over, did I say change in? I meant change in Y over change in X, right? So all of these, again right here, are change in Y over change in X, which is just another way of calculating slope. And the last one, you have a horizontal line. What is the slope of a horizontal line? What is the slope of a vertical line?
Undefined.
If you have a line heading in this direction, what's the slope?
Positive.
If you have a line heading in this direction, what's the slope?
Negative.
The proof on all of these, A, B, C, and D, is located right here. Remember, these X's represent the variables are any number, and then positive and negative just represent the direction in which we're calculating the slope. Questions?